Here is the compound gear train used in this experiment. It contains 8 meshing gears as well as a planetary gear set. The purpose of this experiment is to determine the effect that different meshing gears has on gear ratio and velocity ratio. Also, to understand what effect locking different parts of the planetary gear set has on gear ratio and velocity ratio. This is the planetary gear set included with the experiment. As with all planetary gear sets, it contains a central sun gear surrounded by planet gears and all enclosed with a ring gear. To start the experiment, count and record the number of teeth on every gear in the gear train, as well as the number of teeth on every gear component of the planetary gear set. To conduct the experiment, rotate the shaft 360 degrees in first gear of the normal configuration and record the output angle. This process must be completed for every gear in the normal and the overdrive configurations. Switch between gears as shown and repeat the process. Then switch to overdrive and repeat the process again. In the normal configuration, the ring gear is locked stationary. This is known as a reduction, where the output speed is lower than the input speed. To switch to overdrive, lock the sun gear stationary. This output speed will be faster than the input speed. Gear ratio and velocity ratio will be calculated using the input and output angle, as well as the number of teeth on each gear. Calculating with the number of teeth on each gear gives an exact value of gear ratio, while calculating with the input and output angles give a experimental value, and these should be compared and analyzed accordingly.